Good day, learners. Today I'm going to be focusing on the grade 10 midpoint theorem and its converse. Let's go through the theory aspect first. You will have to know the proof of the midpoint theorem. The midpoint theorem states, if I have a triangle called ABC, and there's a line called XY that does all the work. So it says if XY cuts AB in half, and XY cuts AC in half, then you can conclude that those two lines are parallel, and this length is half of that length. So if this was x, this would be a half x. Okay, that's what the midpoint theorem says. So if you write it, it will say, if AX equals to XB and AY equals to YC, then you can conclude that XY must be parallel to BC and XY is a half of BC. Okay, that's what the midpoint theorem says. The converse, the implication of a converse is that whatever is assumed in a theorem is then accepted in a converse. So properties are swapped around. So the converse says, if I have a triangle called ABC and XY does the cutting, so if XY cuts one side in half and XY is parallel to the base of the triangle, then you can assume that that will equal to that, and that will be a half of that. Writing it mathematically, you'll tell me if AX equals to XB and XY is parallel to BC, then you can add into the drawing that AY equals to YC and XY is a half of BC. Reason for all of this is converse of midpoint. The reason to say this is called midpoint theorem. Okay, midpoint theorem and its converse, the last section of grade 10 Euclidean geometry. Let's move on to doing a rider. Now you understand the concept of a rider.